Hi, and welcome to the third of 3 videos for section 3.3. I know what you're saying again. Now he forgot to erase the board. No, I didn't. Again, there's a reason I left this up. In this video, we're going to look at 2 different theorems. The first one we have is known as the Remainder Theorem. It says the following: if the polynomial p of x is divided by x minus c, the remainder is the value p of c. So if I have a polynomial dividing by x minus c, whatever c is, if I plug that into the polynomial, simplify it, it should tell me what the remainder is. So let's go back to this example that's burning its ink into the board here, right? If I want to divide this by that, so let's call this example, find the remainder. If, let's call this guy p of x. So if p of x, from the previous example, is divided by x minus 3. So that means what? Again, our c is equal to 3. So I just want to know the remainder by the remainder theorem should be p of 3. So if I plug that in, I get 2 times 3 to the third minus 7 times 3 squared plus 5. So if this is true, if this theorem really works, our remainder should be what? We should get negative 4 as an answer. Well, let's see. 3 to the third is 27 times 2 is 54. 3 squared is 9 times negative 7 is minus 63 and plus 5. So 54 minus 63, negative 9, plus 5, lo and behold, like magic, not really magic, it's the remainder theorem, we get negative 4 as an answer. Okay, now we can erase this guy. Moving on, we're not going to use him anymore. So that's the remainder theorem. If you need to find the remainder of a polynomial, if you're dividing by x minus c, just go ahead and plug that value into the polynomial and simplify. The second theorem we have for this video is known as the Factor Theorem. And that says the following: c is a 0, or if you remember before, we called this sometimes a root, of p if and only if, so this is that shorthand notation we've been using, x minus c is a factor of p, or p of x, a polynomial. So, let's look at an example. We want to let p of x equal x to the third minus 7x plus 6. We want to show that p of 1 is equal to 0 and use this to factor p of x completely. So a couple things here. So if our value c is a 0 or is a root of p, x minus c is a factor of p of x. So that means what? If something is a factor, the remainder would be what? The remainder would be 0. So if I have some polynomial, so let's say Let's say I have x squared minus 4. Well, we know these factors are what? It's x plus 2 times x minus 2. So if I was to do the long division, or I could even do synthetic division, but if I was to do this, if let's say I divide this by x plus 2, when I get done here, I'm going to get what? X minus 2, but there's no remainder left because this x plus 2 was indeed a factor. So that's what we're asking for here. First, we want to show that p of 1 is equal to 0. Well, that's straightforward enough. We do what? We just plug in 1 into the polynomial, so we get 1 to the third, minus 7 times 1 plus 6, that's 1, minus 7 plus 6, 1 minus 7 is negative 6 plus 6 is 0. Okay, so therefore we showed p of 1 is equal to 0. So if p of 1 is equal to 0, remember that by the remainder theorem, which I just had, that's what? This 1 is equal to c. So that means one of my factors, because I have to factor this now. And so remember, up until this point, the only way we could factor third degree polynomials is what? With our special factor formulas, if it was a difference of cubes or a sum of cubes. Now we're actually going to be able to divide higher degree polynomials without having to have special formulas. So if c is 1, that means that one of the factors is what? Well, it's x minus c, which would be x minus 1. That's one of the factors of this polynomial. To find the remaining values, we have to do what? Division, but because it's x minus c, we can do synthetic division. So if I do that, I have what? I have 1. I don't have an x squared, that's got to be a 0. Then minus 7, and then 6. It gets that upside down bar. And my value of c is equal to 1. So by synthetic division, what do? First thing, bring down the 1. Multiply these two. 1 times 1 is 1. Bring that up to the second line. Now just add down. 0 plus 1 is 1. Multiply again. 1 times 1 is 1. Bring that up here is 1. Add down. Negative 7 times 1 is negative 6. 1 times negative 6 is negative 6. Add down. Good. That's because remember, that last value is our remainder value. So that means we have another polynomial that when I divided this original by x minus 1, where my c is equal to 1, it gives me this polynomial. So what actually is this polynomial? This is the coefficients, right? So I started with x to the third. Remember, this drops down by 1. So this is really 1x squared plus x minus 6. Can I factor this one? Yes, I can. This will factor into what? This factors into x plus 3, x minus 2. So that's for this part. Don't forget we still have this one up here. So we get x minus 1, x plus 3, x minus 2. That's the complete factorization of this polynomial p of x that we started with. So we knew one of the values. We knew that the remainder was 0. That means it had to be a factor. Once we had that, we could apply synthetic division to get us the polynomial remaining, convert it to what the polynomial is, and now it's a polynomial of degree 2. And you can either just factor it or you could do quadratic formula. All right, let's look at one more example. That'll wrap up the videos for section 3.3. This example says the following. Find a polynomial of degree 4 that has zeros -3, 0, 1, and 5. So, now we're reversing the process. The last problem, it gave us a polynomial, said what are the factors? This one, it's saying here's our zeros or here's our roots. What's the polynomial that has this quality? So that means what? If these are my zeros, if these are my values of c, it's what? It's x minus c, so x minus a negative 3, x minus 0, x minus 1, and x minus 5. And this is where this idea of roots versus our value c gets a little bit tricky, because it's the value we're given for the root, 5, has a factor associated with x minus 5. Because remember, it's that x minus c value, so with that extra negative sign in there, we always have to remember it's the opposite of what we're seeing. So this then is just x plus 3 times x minus 1 times x minus 5. And now it becomes a lot of foiling, essentially, and distributing. So let me bring this x to the front, save that for later. I have my x plus 3, and if I FOIL these two guys, I get what? X squared minus x minus 5x, so that's minus 6x plus 5. Now, keep the x. I want to multiply these two polynomials together. So be careful with your math here. What do we get? We get x times x is x squared minus 6x squared plus 5x. Now move on to the 3 plus 3x. What did I do here? Oh, this should be x squared. Sorry, x squared minus 6x plus 5. So this, x times x, is x to the third. Then minus 6x plus 5x. This guy here is 3 times x squared, so 3x squared. 3 times negative 6x is minus 18x. And 3 times 5 is 15. So let's simplify this. We have x to the third. Now our x squared terms. We have plus 3 minus 6, so that's minus 3x squared. The x pieces, I have plus 5 minus 18, so that's minus 13x. And then plus 15. Then I have this x left on the outside, distribute that in, so I get x to the fourth, a polynomial of degree 4, which is what I wanted, minus 3x to the third, minus 13x squared, plus 15x. So that one's really more of a lot of busy work. You won't be seeing that on an exam. I'm more concerned with you being able to divide these polynomials, know how to use synthetic division, things of that type. This one's really more of a concept check, saying if you know the zeros, do you know how to set it up as a bunch of binomials, and then you can multiply it out. So that's it for 3.3. Come on back, we'll look at section 3.4.